A helicopter is a dynamic machine and demonstrates many fundamental components of Newton's laws of motion. A model helicopter is mounted on a freely rotating turntable. As the main rotor is put into rotation, a clear example of Newton's third law can be seen. The helicopter's engine applies a force to the rotor, causing the rotor to spin in a clockwise direction. The rotor, in turn, applies an equal and opposite force to the engine, causing the helicopter to spin in an opposite counterclockwise direction. The fact that forces always come in pairs poses a significant problem to the helicopter's operation. To overcome this problem, a rear tail rotor is incorporated into the helicopter's design. Its role is to provide a force which counters that of the main rotor, thus preventing the helicopter from spinning uncontrollably. In order to attain the force necessary to become airborne, Newton's third law comes into play once again. As the spinning rotor collides with air molecules, it applies a downward force on them. The air molecules respond by exerting an equal and opposite force on the rotor. It's this upward reaction force that lifts the helicopter off the surface. Forces acting on the helicopter cause it to move or to remain stationary. The pull of the Earth's gravity is always acting on the helicopter. This downward force is called the helicopter's weight. A second force results from the surface pushing upward on the helicopter. This force acts at right angles to the surface and is appropriately called the normal force. Since the weight and normal force are equal in magnitude, the two forces cancel and the net force acting on the helicopter is zero. Newton's first law accurately predicts that the helicopter remains at rest. When the main rotor is spinning, an upward lifting force is added to the helicopter. As the blades rotate faster and faster, the lifting force increases. As soon as the upward lifting force becomes greater than the downward weight, the helicopter accelerates upward. At this point, the forces add together to produce a net force in the upward direction. In accordance with Newton's second law, acceleration takes place in the direction of the net force. The helicopter accelerates upward and then decelerates, eventually coming to a stationary hover. In the hovering state, the lifting force applied by the rotor perfectly balances the helicopter's weight. There is no unbalanced force acting on the helicopter, and it remains in an airborne state of rest. When the nose of the helicopter is pitched downward, the direction of the lifting force changes, acquiring a horizontal component as well as a vertical component. The vertical force component continues to balance the helicopter's weight, keeping it suspended in midair. The horizontal force component, however, has no opposing force working against it. This net force causes the helicopter to accelerate in the forward direction.